Hello everyone. Today I am here with you all with the fourth chapter of class 9th maths, that is linear equations in two variables. So let's start with it. First of all, one should know that what linear equations are. We have already learnt in our previous classes that the equations with degree 1 are known as your linear equation. And if there is only one variable in the equation, then it is known as linear equation in one variable. That means if we are going to take an example, suppose I am going to say 2x plus 3 equivalent to 0. Over here we can see that there is only one variable, that is x, and the degree of this equation is 1. That simply means that the highest power of the variable is your 1. That's the reason this is an example of linear equations in one variable. We have already learnt even that it is having a unique solution, that all the linear equations in one variable is having a unique solution. That simply means there will be exactly one value of the variable that will satisfy the equation, that will be the solution of this equation, that will be the root of this equation. That simply means if we are going to solve it, it will be your 2x is equivalent to minus 3. We have taken this plus 3 in the RHS part, so it has become minus 3, or we can say x is equivalent to minus 3 by 2. That means if we are going to replace in this equation x is equivalent to minus 3 by 2, your LHS part will become equivalent to your RHS part. That simply means it is going to satisfy this equation, so it is the root of this equation. That simply means we can say that the linear equations in one variable is having only one root, a unique root it is having. And we have already learnt even that how to represent these numbers or these roots on the number line. So what we have learnt is, this is your number line. In the center we are having 0. In the right hand side we are having your positive numbers. In the left hand side we are having the negative numbers at unit distance. Now over here we can see minus 3 by 2. That means it will lie between minus 1 and minus 2. Right, because it is minus 3 by 2, that could be written as minus 1.5, or that will lie between minus 1 and minus 2. Now here the denominator is 2, that means we will be dividing minus 1 and minus 2 into 2 equal halves. Suppose this is your one more point. Now what we are doing is, it is your 0, so it will be, the first point will be minus 1 by 2, the second, that is your minus 1. Minus 1 could be written as your minus 2 by 2 even, and this part, that is which in between your minus 1 and minus 2 will be your minus 3 by 2. So this is how we can represent the root of the equation on the number line also. We have also learned that if in the equation we are going to add or subtract any fixed number, matlab same number, both the sides, in the LHS part even and in the RHS part even, then the value of the equation won't change. That means equation will remain as it is. Like I am going to take this example only. It is your 2x plus 3 equivalent to 0. If I am going to add 2 in LHS also and in RHS also, this will become your 2x plus 3 plus 2 equivalent to 0 plus 2, or we can say it as 2x plus 3 plus 2 will become your 5. It is equivalent to 2. So this equation and this equation, it is same. If we are going to solve this even, your root will be same only. If we are going to solve further, 2x is equivalent to 2 minus 5. This plus 5 will go over here, will become minus 5. Or we can say 2x is equivalent to minus 3, or x is equivalent to minus 3 by 2. That simply means if we are going to add or subtract any number, any fixed number, any same number in the LHS also and in the RHS also, then also our linear equations remain same. Its value is not going to be changed. Similarly, we are going to multiply it even or divide it even, both the sides, in the LHS also, in the RHS also, with the same number, then also its value is not going to be changed. Now let's see the same example. 2x plus 3 equivalent to 0. If we are going to multiply this whole equation by 2, so it will become your multiplied by 2 multiplied by 2. So this will become your 2 multiplied by 2 will be your 4x, 2 multiplied by 3 will be your 6. It is equivalent to 0 multiplied by 2 will be your 0. So this will be 4x is equivalent to minus of 6, or we can say x is equivalent to minus 6 by 4 or minus 3 by 2. That simply means if we are going to add, subtract, multiply or divide the equation in LHS also, in RHS also by the same number, then it will remain same. It is not going to be changed. It is all about your linear equations in one variable. Now suppose there is a condition where there are two variables are there. Like suppose I am saying that I have purchased few pens and few pencils, and total of these two. Separately, I don't know how much someone else has purchased or I have purchased. Say some number of pens. Suppose I am saying the number of pens is your X and number of pencils I have purchased is your Y. But total number of pens and pencil, I know that it is 15. So the equation will be X plus Y is equivalent to 15. So over here we can see that there are two variables are there. One is your X and one is your Y. We don't know the separate values of X and Y also, but the degree of this is even 1. Over here we can see the power of X is 1, the power of Y is even 1. That simply means it is having your degree 1. So such type of equations are known as your linear equations in two variables. Over here we can see the degree is 1 and there are two variables are there. So in such type of situations we need to use your linear equation in two variable. Another example I could take, suppose I have taken 5 pens and the cost of the pen, I don't know what the cost of a pen is. I'm assuming that the cost of a pen is your rupees X and cost of pencil is your rupees Y. This is the cost of pen and this is the cost of a pencil. Now suppose I have purchased 5 pens. So cost of one pen is rupees X. So cost of 5 pens will be your 5X. This will be the cost of 5 pens. And suppose I have purchased 7 pencils. So cost of one pencil is Y. So cost of 7 pencils will be 7Y. And if total of 150 rupees, suppose I have paid to the shopkeeper, then the equation will become 5x plus 7y is equivalent to 150. So these type of equations where there are two variables and where degree is 1 are known as linear equations in two variables. The standard form of your linear equation in one variable is your ax plus b is equivalent to 0. This is the standard form of linear equation in one variable. So the root of this equation will be ax is equivalent to minus b, or we can say x is equivalent to minus b over a, where a and b are any real numbers and a cannot be 0. Because if a will become 0, it will become a constant. B is a constant, so it won't be a linear equation in one variable in that case if your a will become 0. So standard form of linear equation in one variable is your ax plus b equivalent to 0, where a and b are any real numbers and a cannot be 0. Now, if we are going to talk about linear equations in two variable, in that case standard form of linear equation in two variable is ax plus by plus c equivalent to 0. Over here we can see there are two variables are there, x and y, and a, b and c are any real numbers. They are constants, they are any real numbers. A, B, C are any real numbers and A and B both cannot be 0. Because if A will become 0, it will become your linear equation in one variable. If B will become 0, then also it will become linear equation in one variable. So for linear equation in two variables, both your A and B cannot be 0. The both of them should have any non-zero value. So this is your standard form of your linear equation in two variable. Now see, if it is your linear equation in one variable, then also we can represent this linear equation in one variable in the form of your linear equation in two variable. How we can represent it? Suppose it is your ax plus b equivalent to 0. It is your linear equation in one variable, and if we want to convert this into linear equation in two variable, what we can write it as? Ax plus 0 multiplied by y plus b equivalent to 0. If we are going to see this equation and this equation, both are same, because 0 multiplied by anything will be 0 itself. That simply means both equations are same, but it is linear equation in one variable and it is linear equation in two variable. That simply means linear equation in one variable could even be written as linear equation in two variables. So this is what about your linear equation in one variable and linear equation in two variables. Standard form of linear equation in one variable is ax plus b equivalent to 0, and standard form of your linear equation in two variables is ax plus by plus c equivalent to 0. If your equation is something like your say 2x plus 3y is equivalent to say 15, suppose. So if we have to convert this into standard form of your linear equation in two variables, then what we will be doing is 2x plus 3y minus of 15 equivalent to 0, because this is the standard form of linear equation in two variable. Over here, if we are going to compare, value of a is your 2, that is coefficient of x, that is 2. Value of b will be your 3, that is coefficient of y, and value of c will be your minus of 15. Instead of x and y, we can take any other variables also, but generally we use x and y only as a variables. So this is the standard form of the variable, and this is how we can compare any of the equation with your linear equation in two variables, and we can find the values of your a, b and c. Now let's see some of the questions from your exercise, that is exercise 4.1. The first question says, the cost of a notebook is twice the cost of a pen. Write a linear equation in two variables to represent this statement. Over here it is given to you that the cost of a notebook is rupees X. Cost of notebook is rupees X, it is given to us, and cost of pen is rupees Y. Now it is given to you in the question that the cost of a notebook is twice the cost of a pen. That means cost of the notebook X is double or twice of cost of your pen. That simply means your condition will be X is equivalent to 2 times of Y, because this is the cost of a notebook and Y is the cost of a pen, and cost of a notebook is twice the cost of a pen. So cost of a pen if it is Y, so twice of it will become your 2y, and both are equal, so this will be the condition. Now if we have to convert this into your linear equation into variables, so we have to convert it into standard form. So it could be written as x minus 2y equivalent to 0. This is the condition, or this is the equation that we have to represent, which shows the statement. Now question number 2, express the following linear equations in the form ax plus by plus c equivalent to 0. That means we have to represent it in the standard form and indicate the values of a, b and c in each case. So first part we are taking, it is your 2x plus 3y is equivalent to 9.35 bar. Bar simply means your 5 is repeating again and again. It is a non-terminating repeating type of decimal representation. So for converting it into standard form, what we have to do is we have to take this 9.35 bar in your LHS. So this will become 2x plus 3y minus of 9.35 bar equivalent to 0. Now if we are going to compare this equation with your standard form of the equation, we can see the value of a is, that is coefficient of x is your 2, value of b, that is coefficient of y is your 3, and value of c is your minus of 9.35 bar. We need to take sign also. So minus will even be included in the value of your c. Now let's see another question, that is your last part of it. That is your 5 is equivalent to 2x. This is only, so last part is your 5 is equivalent to 2x. This is the question, right? So if I am going to write this in the standard form of your linear equation, this will become your 5 minus 2x is equivalent to 0. First of all, we can write this. Now this is your linear equation in one variable. Just now we have seen that if it is a linear equation in one variable also, then also we can convert it into linear equation in two variable. So this could be written as minus of 2x plus 0 multiplied by y plus of 5 equivalent to 0. First of all, I have written this term, that is minus of 2x. Now the another variable I have taken as y, multiplied it by 0 plus 5 equivalent to 0. So this is the standard form of your linear equation in two variable. Now if we are going to compare this with this equation, the value of a will be minus of 2, value of b will be 0, and value of c will be your 5. So this is how these type of questions will be solved. Now let's see what is solution of a linear equation and how to find it out. Just now we have seen that if there is a linear equation in one variable, then it is having a unique solution. That means exactly one solution or unique solution it is having, for which your equation will satisfy. Now if it is a linear equation in two variable, as just now we have said that ax plus by plus c equivalent to 0, is the standard form of the linear equation in two variable. Now we have to find the solution for these type of equations. So what the solution is over here, because two variables are there, one is your x, another is your y. So we will be having pair of values. That means one of the value of x and one of the value of y. If we are going to keep these values in the equation, it is going to satisfy the equation. That means pair of values will be having one for each variable, which is going to satisfy the equation. If it is the condition, that means if I am going to keep the value x in the equation and value y in the equation, your LHS part will become equivalent to your RHS part. So that will be the solution of your linear equation in two variables. So over here we will be having two values, one for each the variable. Now suppose I am going to take an example. Let's understand it with the example. See, I am saying x plus y is equivalent to 7. Now, if I am going to keep x is equivalent to 1 over here, if I will be keeping x is equivalent to 1, so what the equation will become? 1 plus y is equivalent to 7 and y is equivalent to 7 minus 1, or we can say value of y will be 6. That means if the value of x is 1 and value of y is 6, it is going to satisfy the equation, that is your x plus y equivalent to 7. That means 1 comma 6 will be solution of this equation. Here we are writing in the ordered pair only. First we are writing the value of x, then we are writing the value of y. So this is the solution for this equation. If we are going to keep x is equivalent to 1 and y equivalent to 6, it is going to satisfy the equation. Your LHS part will become equivalent to your RHS part. Now the same equation I am taking, and instead of 1, I am going to keep x is equivalent to 2. Over here, I am keeping x is equivalent to 2. So this equation will become 2 plus y equivalent to 7. That means y will be your 7 minus 2, or we can say y will be your 5. That means another pair of your values of x and y for which your equation will become true, or will be the solution of the equation will be 2 comma 5. Where 2 is the value of x and 5 is the value of y. Similarly, we can find other values also. X plus y is equivalent to 7. This is the equation. Now I am keeping x is equivalent to say 3. So this will be 3 plus y equivalent to 7, or we can say y will be 7 minus 3, or value of y will be your 4. That means 3 and 4, this is the ordered pair. That will be means if we are going to keep x is equivalent to 3 and y equivalent to 4 in the equation, it is going to satisfy the equation, or this is the solution of the equation. That means we can find infinitely many solutions for a linear pair of equations in two variables. There are so many infinitely many solutions, many values of x and y, which is going to satisfy the equation. If I am going to keep x is equivalent to 0 over here, if I will be keeping x is equivalent to 0, the equation will become 0 plus y is equivalent to 7, or y is equivalent to 7. So 0 and 7 will be the solution of the equation. Similarly, if I will be keeping y is equivalent to 0, then if I am going to keep y equivalent to 0, the equation will become x plus 0 equivalent to 7, or we can say x is equivalent to 7. So 7 comma 0 will be the solution of the equation. So infinitely many solutions we can have. We can have the value infinitely many values of x and y for which your linear pair of two equations is going to satisfy, will be the solution of the equation. Let's take another example. See, I am going to say y equivalent to 2x. Now if over here I am going to keep x is equivalent to 1, then y will be your 2 multiplied by 1, y will be your 2. That means value of x is 1, value of y is 2. This is the solution of this equation. Similarly, if I am going to keep x is equivalent to 2, so equation will be y is equals to 2 multiplied by 2, or y is equivalent to 4. So x is 2 and y is 4 is the solution of the equation. Now very easy it will become if I'll be keeping once I'll be keeping x is equivalent to 0, once I'll be keeping y is equivalent to 0. So suppose I am keeping x is equivalent to 0, so y will be your 0. 2 multiplied by 0 will be 0. So 0 comma 0 will even be the solution of the equation. So we can see there could be infinitely many solutions, many values of x and y for which your equation will become true. That means that will be the solution for the equation. So we can conclude that there are infinitely many solutions for linear equations in two variable. For the linear equations in one variable, we were having a unique solution. but in the case of linear equations in two variables, we are having infinitely many solutions for the equations. Now let's take some questions from the exercise 4.2. Question number 1. Which one of the following option is true and why? The question is y is equivalent to 3x plus 5. This is the equation given to us. Y is equivalent to 3x plus 5. It has a unique solution, only two solutions, infinitely many solutions. So just now we have seen for the linear equations in two variables, we are having infinitely many solutions. So option 3 will be the answer, that is infinitely many solutions. We can just solve it even if we are going to keep x is equivalent to 1. So this equation will become y is equivalent to 3 multiplied by 1 plus 5. 3 plus 5 will be 8. So 1 comma 8 will be the solution. If I am going to keep x is equivalent to 0, so value of y will be 0 plus 5, that is value of y will be 5. That means 0 comma 5 will be one of the solution. If I am going to keep x is equivalent to 2, then y will be your 3 multiplied by 2 plus 5, that is 6 plus 5, 11. That means 2 comma 11 will be the one of the solution. So there could be infinitely many solutions for any given linear equations in two variables. Now the question number 2, write 4 solutions for each of the following equations. Fine, so I am taking the second equation, that is your pi x plus y equivalent to 9. Now over here, if I am going to keep x is equivalent to 0, in that case this part will become 0. So it will be 0 plus y is equivalent to 9, or we can say value of y will be your 9. So 0 comma 9 will be one of the solution. If I am going to keep x is equivalent to 1, in that case your pi multiplied by 1 will become pi only. Pi plus y is equivalent to 9 and y will be your 9 minus pi. So values will be, solution of the equation will become x is your 1 and y is your 9 minus pi. This is one of the solution. If I am going to keep y is equivalent to 0, because it is very easy, if we will be taking x is equivalent to 0 and y is equivalent to 0 one time, we can take it. So this equation will become pi x plus 0 is equivalent to 9, or we can say x will be 9 upon pi. So solutions will be 9 upon pi will be the value of x and value of y will be your 0. It is comma, so comma 0. This is the solution of the equation. Now we have to find the 4 solutions. So we can take x is equivalent to 1 we have taken, 0 we have taken, so we are taking 2. So this equation will become 2 multiplied by pi plus y is equivalent to 9, or we can say y is equivalent to 9 minus 2 pi. So the solution, your solutions will be x is equivalent to 2 and y is equivalent to 9 minus 2 pi. So this is how we can find infinitely many solutions for any given equation. Now the question number 3, check which of the following are solutions of the equation. Equation is your x minus 2y is equivalent to 4, and which are not. So first we are checking the first solution which is given to us, 0 comma 2. So by convenience, our first value which is given to us will be of x and the second value which is given will be of y only. So we are taking the LHS part. In the LHS, we will be replacing x by 0 and y by your 2. So this will become x is 0 and y will be your 2. So this will be minus of 4. But it is not equivalent to your RHS. RHS is 4, but our value is coming minus 4. That means 0 comma 2 is not a solution of the equation. It is not a solution because when we are keeping x is equivalent to 0 and y is equivalent to 2 in the equation, it is not going to satisfy the equation. Your LHS part is not becoming equivalent to your RHS part. So it is not the solution. Now let's try the third part, that is 4 comma 0. 4 comma 0, let's try. So if I'll be keeping x is equivalent to 4 and y is equivalent to 0, your LHS part will become x is your 4 and y I am taking as 0. So 4 minus 0, that is your 4, and it is equivalent to your RHS. That means 4 comma 0 is a solution of this equation. It is the solution of the equation. That means if we are going to keep x is equivalent to 4 and y is equivalent to 0 in this equation, your LHS part is becoming equivalent to your RHS. It is going to satisfy your equation. Though this is the solution of the equation. Now let's see question number 4. Find the value of k if x is equivalent to 2, x is equivalent to 2 and y is equivalent to 1 is a solution of the equation 2x plus 3y is equivalent to k. This is the equation given to us, and it is also given to us that x is equivalent to 2 and y is equivalent to 1 is the solution of the equation. That means if we will be replacing x by 2 and y by 1, it is going to satisfy the equation. Your LHS part will become equivalent to your RHS part. So just put x is equivalent to 2 in this equation and y is equivalent to 1. So it will become 2 multiplied by 2. Instead of x we have taken 2, and 3 multiplied by 1. Instead of y we have taken 1. It is equivalent to your k. So it will be 2 multiplied by 2 will be 4. 3 multiplied by 1 will be 3. It is the value of k, or we can say value of k will be your 7. So this is how we can find the solutions of any linear equations in two variables, and we can solve related questions. Just now we have seen how to find solutions of a linear equations in two variables algebraically. Now let's see how we can represent the linear equation in two variables graphically. So we have taken, suppose I have taken an equation that is your x plus y equivalent to 4. So we can find the solutions of this equation. Just now we have seen how to find the solutions of this equation. So how we will be doing it? First of all, we will be making a table. In this table, two variables are there. So we'll be taking two variables. One is x, one is y. And the values of x and y for which your equation will become true, or which will be the solutions of this equation. Now over here we can see if I am going to keep x is equivalent to 0 in this equation, if I am going to keep x is equivalent to 0, the value of y will be your 4. It is 0 plus y is equivalent to 4, and that simply means value of y will be your 4. That means if a value of x is 0, value of y will be 4, and it is going to satisfy the equation. It will be the solution of the equation. Now if I am going to keep y is equivalent to 0, if y will be 0, the value of x will be your 4. If y is equivalent to 0, the equation will become x plus 0 equivalent to 4, or we can say value of x will be 4. Now if I am going to keep x is equivalent to 1, the equation will become 1 plus y is equivalent to 4, and the value of y will be 4 minus 1, that is 3. That means if value of x is 1, the value of y will be 3. Similarly, more solutions we can find. If I am going to keep x is equivalent to 2, so the equation will become 2 plus y is equivalent to 4, or we can say y will be 4 minus 2, that is your 2. So value of x is 2, so y will even be 2. If I am going to keep x is equivalent to 3, the value of y will be 1. And if I am going to keep x is equivalent to say minus 1, in that case, if I am going to keep x is equivalent to minus 1, so it will be minus 1 plus 5 is equivalent to plus y is equivalent to 4, or we can say value of y will be 4 plus 1, that is your 5. So if value of x is minus 1, in that case value of y will be your 5. This is how we can find the solutions of the given linear equations in two variables. Now if we are going to represent this graphically, so in the last chapter, that means coordinate geometry, we have seen how to plot the points. If the values of x and y we are having, how we can plot it on the graph. So over here in the center we have taken 0. In the right hand side we have taken positive numbers. This is your x dash axis, and this is your y dash axis. So over here I have taken till 6. In the negative direction I have taken these points. In the y direction, positive y, this is your positive y, so taken positive numbers. Downwards it is your negative y direction, so taken negative numbers. This is how we have made the x axis and your y dash axis. Now first of all we will be plotting your 0, 4. This is the coordinate. So coordinates will be your 0, 4. This is one of the coordinate. Then your 4, 0, 1, 3. First we will be writing the x coordinate, and then we will be writing the y coordinate. This is only the way we are going to represent any of the coordinates of a point. So 0 comma 4, that means x coordinate is 0 and y coordinate is 4. So if x coordinate is 0 and y coordinate is 4, this is the y axis. So y is 4 here. So this will be the point. Now the second point, if I am going to take, it is your 4 comma 0. Over here x is 4 and y is 0. So x is 4 in this direction. So 4 is here, and because y is 0, that means it is going to lie on the x-axis. On the x-axis, your y coordinates are always 0, and on the y-axis, your x coordinate is always 0. So this point, because x coordinate was 0, it is going to lie on the y-axis. The second point in this, your y coordinate is 0. That's the reason it is going to lie on the x-axis. So if we are going to join these 2 points, it is going to make a line. Now, if I'll be seeing 1 comma 3, this is even a solution of this equation. That means x coordinate is 1 and y coordinate is 3. So x coordinate is 1 and y coordinate is 3. If I am going to draw the perpendiculars, so it is going to intersect over here. That means this is a solution. 1 comma 3 was the solution, and this 1 comma 3 is lying on the line, this line only. This point was your 4 comma 0, this point was your 0 comma 4. Now the next point was your 2 comma 2. So that means x coordinate is 2 and y coordinate is even 2. So here x coordinate 2 and y coordinate 2, from both the sides I'll be drawing the perpendiculars. The points are going to meet at this point, and this point is even lying on the line only, this line only. Now the next point is your 3 comma 1, that is x coordinate is 3 and y coordinate is 1. So this is your x coordinate. From here I am going to draw the perpendicular, and from 1 also I am going to draw the perpendicular. This is even meeting at this point only, which is on the line. That simply means the points which is going to satisfy the equation, all these points will lie on the line only. Whenever we are going to represent any linear equation in 2 variables, its graphical representation will always be a straight line. When we are taking any 2 points or any 3 points, if we are going to draw any 2 or 3 points which are going to satisfy this equation, that means which are the solution of this equation, if we are going to plot any 2 points or any 3 points on the line, and if we are going to join them, it will be always a straight line. And because the graphical representation of linear equations is a line, that's the reason the equation of 1 degree is known as your linear equation, because their graphical representation is a straight line. Now over here we can see we have taken only 2 points. Initially we have taken only 2 points, only 2 solutions of this equation, and if we have joined, we got a line. Now whatsoever the points are coming, like whatsoever the solutions were there, all these solutions were lying on this line only, the line which we had drawn initially using your 2 solutions only. What we had done initially, we have taken only 2 solutions, we have plotted these 2 solutions and we have joined it and we got a line. Now whatsoever the solutions were there, all these were the solutions for this equation only. So whatsoever the solutions were there, when we have plotted these solutions on this graph, what we noticed that all these points are lying on this line only. On this line only, that is your AB. If this line is your AB, then on this line AB only all these points are lying, right? Similarly, what we can say is whatsoever the solutions of this linear equation in 2 variable will be, it is going to lie on the given line. And if I am going to say, suppose I am going to take this point. This point here, we are intersecting, the intersection from this point I have drawn a perpendicular on the x-axis also, and from the on the y-axis also. So this point, coordinates of this point will be your 5 comma minus 1, right? So this point 5 comma minus 1 is even going to satisfy this equation. We can see over here 5 comma minus 1, if I am going to keep over here, that means x is equivalent to 5 and y is equivalent to minus 1. If I will keep in this equation, so your LHS part will become x is your 5 and y is your minus 1. So 5 minus 1, that is 4, and it is equivalent to your RHS. That means whatsoever the point will lie on this line AB, every point will be the solution of this given equation. So what we can conclude is, whenever we'll be plotting graphically any of the linear equation in two variables, it will always be a straight line. Whatsoever the solutions of the equation we'll be getting algebraically, all these solutions will be on this line only. All these points will be on this line only. And we can conclude that if we are going to take any point on this line, then this will be the solution of the equation. Just now we have seen one of the example. Another example we can see, from here I have drawn a perpendicular on this line. Suppose this is the perpendicular, and from here also I have drawn the perpendicular. So it is the point of intersection of these two perpendiculars. That means this point is your x coordinate is your 6 and y coordinate is -2. That is your 6 comma -2 is on this line. Now if I will be checking this point on your this linear equation, so your x plus y is equivalent to 4, x is equivalent to, I'll be taking 6, and y is equivalent to, I'll be taking -2. That means if I'll be taking these values, what the LHS part will become, x is your 6 and y is your -2. That is 6 minus 2, that is 4, and it is your RHS. That means every point which is coming on this line AB will be the solution of this equation, right? Now one more thing, suppose I am going to take a point, say I am taking this point. This point I am taking, here x coordinate is your 2 and y coordinate is your -3. If I'll be taking this on this your equation, then your equation was your x plus y is equivalent to 4. I am keeping x is equivalent to 2 and y is equivalent to -3. So your LHS part will become x is 2 and y is -3. That is 2 minus 3, that is -1, and it is not equivalent to your RHS. That simply means if we are going to take any other point which is not coming on this line AB, then it is not going to satisfy the equation. It will not be a solution of this given equation. So just now what we all discussed is, we have taken a linear equation in two variables. Algebraically we have solved it and we have found the solution of this equation, right? Now from these coordinates ordered pair, we have taken any two. From any two, because we can take any three also, so that it will be more easy for us to plot a line. So we have taken either two or any 3 points, we have plotted it on the graph. Now we have joined these 2 or 3 points whatsoever we have drawn. If we will be joining this, it will always be a straight line. Now if remaining 3, now suppose we have taken these 3 points initially, we have plotted the graph using these 3 points. If we will be checking remaining points, then these points are going to come exactly on the line AB only. It will be on the line AB. This is one of the conclusion we can see. Another is, if we are going to take any point on this line, suppose I have taken this point or we have taken this point, whatsoever the point we will be taking on the line, if we will check it for your solution of the equation, it is going to satisfy the equation. That means that will be the solution of the given equation. And if we are going to take any other point which is not on the line AB, then it will not be the solution of the given equation. So this is what we can conclude, how we can just plot the linear equation in two variables graphically. Now suppose one more example I am taking, say y is equivalent to say 5x. This is an equation I have taken. Now if I'll be plotting it, first of all I'll be finding the solution of this equation algebraically. So if I'll be keeping x is equivalent to 0, so y will even be your 0, right? So I'll be making a table. This is a table in x and y. If x is 0, y is even 0. If x is equivalent to 1, so y will be 5 into 1, that is your 5. If x is 1, y will be 5. If x is your 2, so y will be 5 into 2, 10. If x is equivalent to -1, so y will be minus of 5, right? Similarly, if x is equivalent to -2, y will be minus of 10. Now, if we are going to represent this graphically, how its representation will be? Now, see, the numbers are coming very big. So, instead of every unit distance, I am taking distance of your 5, 5. So initially in the center I have taken 0, then I have taken 5, then I have taken 10, then I have taken 15, like that I have taken here minus of 5 at the same distance. Distance between the two, gap between the 2 points will remain same. It is your minus of 15, it is positive 5, it is positive 10, like this I have taken. This is your x dash axis, this is your y dash axis. Here even I have taken minus 5, minus of 10, minus of 15, minus of 20, like this. Now the first point is your 0, 0, that means origin. This is a point, right? Now the another is your 1, 5. The pair is your 0, 0. Then it is your 1, 5. X is 1, y is 5. Then 2, 10. Then your minus 1, minus 5. Then your minus 2, minus 10. Like this. These are the solution for this equation. Now I am plotting 1, 5. So 1, 5. So it is very difficult for me to plot it right now because I have taken a gap of 5, 5. So if it is 1, this point 1, suppose I am taking this is 1. So y will be your 5. That means it is going to lie somewhere here. If your x is 2, y is 10. If x is 2, y is 10, that means it will lie somewhere here. So your graph will be like this. This will be the graph. That means if your equation is of the form y is equivalent to say mx or kx or whatsoever, any of the this form, if it is of this form, then always and always your graphical representation will pass through center. Why it will happen? Because see, if you are going to keep x is equivalent to 0 over here, y will even become 0 because constant part is not there. It is of the form y is equivalent to kx. Here c is not there. Your ax plus by plus c equivalent to 0. Over here your c is 0. So if it is of this form, then if x will be 0, y will even be 0. That means one of the coordinate, one of the solution of this equation will be your 0, 0. That simply means this type of graph will always pass through your origin. So this is how we can first of all find the solutions algebraically, then we can represent it graphically also. Now let's see some questions from the exercise. Say, draw the graph of each of the following linear equations in two variables. See, x plus y is equivalent to 4. We had already taken this question. How to plot it? We have done. Give the equations of two lines passing through 2, 14. This is a point 2, 14. We have to find the equations which will pass through this point. How many more such lines are there and why? See, if I am going to say, first of all, I am simply taking x plus y. If I will be keeping x is equivalent to 2 and y is equivalent to 14. So 2 plus 14 will become 16. So your equation will become x plus y is equivalent to 16. Right? This is the solution of the equation. We have to frame the equation. Right? So here we can see this is 2, this is 14, value of x is 2, value of y is 14. So if x is 2 and y is 14, your this part, so we have taken, now 2 plus 14 will be 16, so we have equated it equivalent to 16. This is one of the equation. Here simply we can see that the value of y is 7 times your value of x. That means y is your 7 times of x. This is even another equation, because if you will be keeping x is equivalent to 2, 7 into 2 will become 14. So it is y is equals to 7x will be the another equation. Now if I will be taking say y minus x, because value of y is greater than value of x, so I have taken y minus x. So y is your 14, 14 minus 2. 14 minus 2 will be 12. So equation could be y minus x is equivalent to 12. So this is how you can frame multiple or infinite of equations using any of the coordinate given to us. The third point is, question is, if the point 3, 4 lie on the graph of the equation, coordinate is given to us as 3, 4. It lies on the equation 3y is equivalent to ax plus 7. Find the value of a. Over here it is given to you that 3, 4 is the solution of this equation. It is already given to you. That means we have to replace x by 3 and y by 4 in this equation. So if we will be replacing x is equivalent to 3 and y is equivalent to 4, this equation will become 3 multiplied by 4. It is equivalent to a multiplied by 3 plus 7. So 4 3s are 12 is equivalent to 3a plus 7. So this 7 I am taking in the LHS part. It will become 12 minus 7. It is equivalent to 3a. So it will be 5 is equivalent to 3a, or we can say value of a is 5 upon 3 will be the value of the a. Now the next question is, the taxi fare in a city is as follows. For the first kilometer, the fare is rupees 8. For the first kilometer, fare is 8, and for the subsequent distance, it is rupees 5 per kilometer. Then after first kilometer, it is rupees 5 per kilometer. Taking the distance covered as x kilometer. Distance covered is your x kilometer. Distance covered is your x kilometer. It is given to us. And total fare is y. Total fare is your rupees y. It is given to us. Now write a linear equation for this information and draw its graph. So see over here, total fare is your rupees y and total distance covered is x. For the first kilometer, your fare was 8 rupees, and for rest all the kilometers it was 5 rupees. That means for the first kilometer, if it is x, if it is 8 rupees, so remaining distance will be your, for which you are paying 5 rupees, will be your x minus 1 kilometer. Right, total distance is your x kilometer. For the first kilometer you are paying 8 rupees, right? For the first kilometer you are paying 8 rupees. So for how many kilometers you are paying 5 rupees? For x minus 1 kilometer, because total distance is your x kilometer. So first kilometer you have paid 8 rupees. For the remaining x minus 1 kilometer you will be paying 5 rupees. For 1 kilometer it is 5. So for x minus 1 kilometer it will be 5 multiplied by x minus 1, and total fare is your y rupees. So it will become 8 plus 5 multiplied by x will be 5x minus of 5 if equivalent to y. So it will become your 5x. This y I am taking over here, so will become minus of y. 8 minus 5 will be your 3 plus 3 equivalent to 0. So this will be the equation, that is 5x minus y plus 3 equivalent to 0. Now you will be keeping the values of x and y, finding the algebraically, you will be finding the solution, and then you can represent it graphically. Then your question is, from the choices given below, choose the equation whose graphs are given. See your this graph 4.6 first one, 4.61. Your equation is y is equivalent to x. The solutions for the equations are given to you. That means the points which are lying on this line are given to you as 0, 0. This is the point. Then it is your minus 1, 1. This is even solution of the equation. And 1, minus 1. This is even solution of the equation. It is given to us. These are the points which are lying on the line given graph of your question. Now see, the 4 equations are given to you. Y is equivalent to x. X plus y equivalent to 0. Then your y is equivalent to 2x, and your 2 plus 3y, 2 plus 3y is equivalent to 7x. Now we have to select that for which equation these are the solutions. See over here, 0 is equivalent to 0, it is satisfying this equation. If x is 0, y is even 0. Right? Now this 0, 0 is satisfying this. Now check the another point, minus 1, 1. If x is minus 1, your y will even be your minus 1 in that case, because x is equivalent to y. Whatsoever the value of x will be, the value of y will be the same. That simply means it is not the equation. Now we are checking for the second equation. Over here, if x is 0, y is 0, so 0 plus 0 is 0, right? This point is satisfying this equation. Now we are taking the second point, that is minus 1, 1. So if I will be keeping x is equivalent to minus 1 and y is equivalent to 1, your it will become your 0, and it is also your RHS. So that means this point is even satisfying your x plus y equivalent to 0. Now let's check the third point, that is your 1, minus 1. If I will be keeping x is equivalent to 1 and then y is equivalent to minus 1, then it will be 1 minus 1, that is 0, and it is equivalent to RHS. That means all these 3 points are satisfying this equation. So this will be the answer. This will be the equation. Now let's see the another question. if the work done by a body on application of a constant force is directly proportional to the distance traveled by the body. Work done is directly proportional to distance traveled. And constant is your force. So force is constant. So it will be F into D. When we will be removing the proportionality sign, we will be taking any of the constant, and constant over here is force. So W is equivalent to F into D. We can take your work done equivalent to your Y, because we have to plot the graph in terms of your Y and X. So we can take this as Y is equivalent to F into 5. You can X into X. Means distance traveled we have taken equivalent to your X, and your work done we have taken equivalent to your Y. Now express this in the form of an equation in two variables and draw the graph of the same by taking the constant force as 5 units. Force we have to take as 5 units. If force is 5 units, so your equation will become Y is equivalent to 5x. Now you can just graphically you can find the solutions and then represent it. Just we have solved this, even Y is equivalent to 5x. This equation we have solved just now. So this is how the graph will be, which is going to pass through your origin. Then you have to check it for 2 units. We have solved it even for 2 units. It will be your 10. If value of x is 2, value of y will be your 10. Like this it could be done. Then the next question is, Yamini and Fatima, two students of class 9th of a school, together contributed rupees 100 towards the Prime Minister's Relief Fund to help the earthquake victims. Write a linear equation which satisfies this data. You may take their contribution as rupees x and rupees y. See, we have taken the contribution of Yamini as rupees x and contribution of Fatima as rupees y. So total of this is your 100. So your equation will be x plus y is equivalent to 100 will be the equation. Now you will be keeping the values of x. For that you will be getting the values of y. Similarly, you can find your solutions of this equation algebraically. Then you can plot it on the graph. Question number 8. In countries like USA and Canada, temperature is measured in Fahrenheit, whereas in countries like India, it is measured in Celsius. Here is a linear equation that converts Fahrenheit to Celsius. The relation is given to us. We have to plot it graphically. One you will be taking as y, one you will be taking as x. You can take f as your y and you can take c as your x. So your equation will become y is equivalent to 9 upon 5x plus 32, or you can take it as f and c also. Anyhow, you can represent it. Now draw the graph of the linear equation above using Celsius for x-axis. It is already given to us that we have to take Celsius as x-axis and Fahrenheit for your y-axis. That means on the y-axis we will be considering the Fahrenheit. On the x-axis we will be considering the Celsius. If the temperature is 30 degrees Celsius, what is the temperature in Fahrenheit? See, the relation is given to us as Fahrenheit is equivalent to 9 upon 5 multiplied by C plus 32. This is the relation given to us. Now the question says if the temperature is 30 degrees Celsius, that means value of C, if it is 30, what will be the value of F? So just replace your C by 30. So F will become 9 upon 5 into 30 plus your 32. 5 6 is 30, 6 9 is 54 plus 32, that is your 86 Fahrenheit. It will be your 30 degrees Celsius will be your 86 degree Fahrenheit. It will be the answer. Similarly, we can solve other questions. So it must be clear to you that how we can represent graphically the linear equations in two variables. Now let's see equations of the lines parallel to the x-axis and y-axis. We have already seen that the coordinates like your 2, 0, if I am saying minus 5, 0, 7, 0, all these type of points where your y coordinate is 0, then these type of points will lie on your x-axis. If we are going to plot it, this is your x-axis and this is your y-axis. Here your origin 1, 2, 3 positive numbers we have taken in the x direction. Negative numbers we have taken here in the y direction. Even we have taken the positive numbers, and here also we have taken the negative numbers. Now if we are going to represent these points 2, 0, over here we can see the x coordinate is 2 and y coordinate is 0. So the point will be 2, 0 will be here. Similarly minus 5, 0, minus 5 it will be somewhere here. This is minus 5 comma 0 because y coordinate is 0 over here. This is 7 comma 0. It will lie even over here on this OX line. Now the points where your y coordinates are 0, these type of points lie on your x-axis, and that's the reason the equation of your x-axis is your y equivalent to 0, because whatsoever the points will lie on the x-axis, for these points your y coordinate will be 0. Similarly, we are going to see 0, 2, 0, minus 1, 0, 5. These points, here your x coordinate is 0 and y coordinate is 2. So the point will be this is the point 0, 2. If your x coordinate is 0, y coordinate is minus 1, then this will be the point. That means the points for which your x coordinate will be 0, the points will lie on your y-axis. And that's the reason the equation for the y-axis is your x equivalent to 0 is the equation for your y-axis. Now, if we are going to say x is equivalent to 2, this is your representation. This is your linear equation in one variable also, and it could even be represented as linear equation in two variable. If this is the condition, so if we are going to represent it on the number line, simply we can take a number line 0 here. In the positive direction we have taken the numbers, in the negative directions we have taken the number. Here x is equivalent to 2, that means this is the point which is to be located. If on the number line we have to represent, we can represent it like this. Now if we have to convert this into linear equations in two variables, then this could even be written as your x minus 2 equivalent to 0, and then it could even be written as x plus 0 multiplied by y minus 2 equivalent to 0. So this has become your linear equations in two variables. Now over here, if we are going to find the solutions for this equation, so we can see that the solutions will be, this is your x, this is your y. If we are going to keep y is equivalent to 0, value of x will be your 2. We can write this as, I have taken y is equivalent to 0. So x plus 0 minus 2 equivalent to 0, it will be value of x will be your 2. If I am going to keep y is equivalent to 1, in that case 0 multiplied by 1 will be 0 only. So value of x will be 2. If I am going to keep y is equivalent to 2, if I have taken y is equivalent to 2, the equation will be x plus 0 multiplied by 2 will be 0. That simply means value of x will be your 2 only. So whatsoever the value of y I will be taking, the value of x will always be 2. It could be 3, it could be 4, because 0 multiplied by any number will be 0. So the value of x will always be 2. Value of x will always be 2. Now if we are going to plot this graph, means solution of this equation, if we are going to plot the equation, this equation x is equivalent to 2, or we can say x plus 0 into y minus 2 equivalent to 0 on the graph, how its graph will be? First we are taking the coordinates 2, 0, 2, 1, 2, 2, 2, 3. These are the coordinates. So 2, 0, x coordinate is 2 and y coordinate is 0. So this is the point. Now the second is 2, 1, x coordinate is 2 and y coordinate is 1. So this is 2 and this is your 1. So here the point will be x is 2 and y is 1. So this will be the point. Now your 2, 2, that means x is even 2 and y is even 2. So x is 2 and y is 2. This point will be. Then your 2, 3, x is 2, y is 3. So this is the point. So if we are going to join this, it will be a straight line which will be parallel to your y-axis. So if we are going to see if there is any equation of this form, like x is equivalent to 2, x is equivalent to 5, x is equivalent to minus 7, any such equation, if we are going to plot it graphically, it will be a line parallel to your y-axis. Similarly, if your equation is, say, y is equivalent to 3, and if we are going to represent this on the number line, so simply y is equivalent to 3, that means if this is your number line, so this is your representation. And if we want to convert this into linear equation in two variables, first of all we will write 0 into x plus y minus 3 equivalent to 0. Now again we will be making a table like this. We will be finding the solutions of this equation x, y. Now whatsoever the value of x I will be taking, because 0 multiplied by that number will be 0 only. It is not going to make any change in the value of y. Y will always remain 3 whatsoever the value of x we will be taking, because it is going to multiply by 0 only. So if x is 1, so 0 multiplied by 1 will be 0. So y value of y will be your 3 only. If I'll be taking x is equivalent to 2, then also 0 multiplied by 2 will be 0. Value of y will be 3. If I'll be taking x is equivalent to 3, y will be 3. X is equivalent to 4, y will be 3. So if we are going to plot all these points on the graph, it will be x's coordinates. First of all, we'll be writing 1, 3, 2, 3, 3, 3, 4, 3. So first is your x coordinate is 1 and y coordinate is 3. X coordinate is 1 and y coordinate is 3. This is the point. X coordinate is 2, y coordinate is 3. X coordinate is 2, y coordinate is 3. This is the point. X coordinate is 3, y coordinate is 3, x coordinate is 3, y coordinate is 3. So if we are going to join all these points, it will be a line parallel to your x-axis. So whensoever we'll be taking any equation of the form x is equivalent to any number, then these type of equations will be a line parallel to your y-axis. Graphical representation of these type of lines will be parallel to your y-axis. And if we are going to take any equation of the form y is equivalent to 3, y is equivalent to minus 5, y is equivalent to 7, then these type of equations, if we will be representing it on the graph, then they will be forming a line parallel to your x-axis. Why it is happening? We can see if it is your equation. Say I am taking another example. I am saying x is equivalent to say 4. This is an equation. So whatsoever the value of y you will be taking, because what the equation will become, x multiplied by 0 into y minus of 4 equivalent to 0. This will be the linear equation in two variables for x is equivalent to 4. Now whatsoever the value of y you will be keeping, the value of x will always be your 4 only. That means your solution will be of the form x will always be 4 and y could be any number. I am saying so y equivalent to y only. Now you can keep y is equivalent to any number, the value of x will always be 4. So these type of lines will be lines parallel to your y-axis. Now if your equation is like this, y is equivalent to say minus of 1, then in linear equation in two variables, this could be written as 0 multiplied by x plus y. This minus 1 will come in the LHS, will become plus of 1 equivalent to 0. Now whatsoever the value of x you will be keeping over here, it is not going to make any change in the value of y. Value of y will always be your minus 1 only. So this type of formation, if you will be finding the solution for these type of equations, it will always be your x could be any number, y will always be your minus 1. So solution for this type of equations will be x comma minus 1, because y will be same whatsoever the value of x you will be taking. Similarly, for this type of equation, your value of x will always be 4 whatsoever the value of y you will be taking. So this is how you can represent this. If you will be considering these as your linear equation in one variable, then it will be represented on the number line. And if you are taking these as a linear equation in two variables, then these lines will be either parallel to your y-axis or it will be parallel to your x-axis. Now let's see the question from your exercise. Exercise 4.4. Your first question we are seeing, give the geometrical representation of y is equivalent to 3. Y is equivalent to 3 as an equation in one variable and an equation in two variables. So see, if we are going to represent this as your linear equation in one variable, in that case it will be represented on the number line. It is 0, it is 1, it is 2, it is 3, it is minus 1, minus 2. So y is equals to 3. This is the representation. This is how we can represent it on the number line if it is linear equation in one variable. Now, if it is your linear equation in two variable, so y is equivalent to 3 could be written as y minus 3 equivalent to 0, and it could even be written as 0 multiplied by x plus of y minus 3 equivalent to 0. Now whatsoever the value of x you will be taking, the value of y will always be 3. Now make a table like this. You can make a table and find the solutions. This is your x, this is your y. If value of x is 1, 0 multiplied by 1 will be 0 and y will be your 3. If you will be taking x is equivalent to 2, 0 multiplied by 2 will be 0 and it will be value of y will be 3. So whatsoever the value of x you will be taking, value of y will always be 3. Now if we will be representing this on the number on your graph, so your coordinates will be coordinates of the points of the solutions. It is your this. Now represent this on the graph. 1 comma 3 means value of x is 1 and value of y is 3. So if I am going to represent it like this, this is 0, 1, 2, 3, 4, 5, 1, 2, 3, 4. This is x dash, this is y dash, this is minus 1, minus 2, minus 3, this is minus 1, minus 2, minus 3, like this. Now x is 1, y is 3. So x is 1, y is 3. From here we will be drawing the perpendicular, from here we will be drawing the perpendicular. So this will be the point. X is equivalent to 2, y is equivalent to 3, x is equivalent to 2, y is equivalent to 3. So if we will be taking it like this is the point. X is equivalent to 3, y is equivalent to 3. From x is equivalent to 3, we will be making it, this is the point. So if we will be plotting it, it will be a straight line like this, which will be parallel to your x-axis. This is a representation if it is your linear equation in two variables. Now the next question is, give the geometric representation of 2x plus 9 equivalent to 0 as an equation in one variable and in two variable. Now see, if we are going to write it in one variable, it will be 2x is equivalent to minus 9 and value of x will be minus 9 upon 2. So this can be represented on the number line. Value of x is equivalent to minus 9 by 2. So here we can see it is your minus of 4.5 basically. Right? That means it will lie between minus 4 and minus 5. So if we are going to represent it, it is your minus of 3, minus of 4, minus of 5. Now the denominator is 2. That simply means we will be dividing minus 4 and minus 5 into 2 equal halves. So somewhere here there will be a point. So minus 4 could be written as your minus 8 by 2 also, and minus 5 could be written as minus 10 by 2 also. So the point exactly in between these two will be your minus 9 by 2. So this is how on the number line we can represent it if it is your linear equation in one variable. Now if it is your linear equation in two variables, how we will be writing it? First of all, it was your 2x plus 9 equivalent to 0. So this could even be written as 2x plus 0 into y plus 9 equivalent to 0. Now whatsoever the value of y you will be taking, the value of x will always be minus 9 by 2. If you will be taking y is equivalent to 1, then also x will be minus 9 by 2. If you will be taking y is equivalent to 2, then also it will be your x is equivalent to minus 9 by 2. So whatsoever the value of y we will be taking, it will always be your x is equivalent to minus 9 by 2. So if you will be representing it graphically, it will be a line parallel to your y-axis. It will be minus 4 and 5, in between minus 4 and 5 exactly. This will be like this. The line will be something like this. It will lie between minus 4 and minus 5. The value of x will always be minus 9 by 2, and whatsoever the value of y you will be taking. So the representation of this in two variables will be a line parallel to your y-axis. So this is all from this chapter. Hope it is clear to you how to find the solutions of your linear equations in two variables graphically, how to find its solutions by your algebraic methods. Now soon we'll be coming with the more chapters, videos on the more chapters from your class 9 syllabus. If you have not yet subscribed my channel, please subscribe it. Thank you.